So we have seen CRD, which is completely randomized design in the last class, and we have also seen how to solve the problem based on this. Now let's go to the next part of this. When we talk about the two parameter, when you talk about the two parameter, it's like two-way ANOVA. It is based on two-way classification if the total experimental area is not homogeneous. So when do you use this homogeneous randomized block design? When your total experimental area is not homogeneous and fertility in gradient in only in one direction. Okay, so the total area, like total experimental area, is not homogeneous and fertility in gradient in only in one direction. So one can use this RBT. Instead of using one-way ANOVA, one can use like two-way classification, two-way ANOVA. Suppose we want to compare the effect of P treatments where each treatment is replicated Q times as we have a Q blocks. So we need N is equal to PQ plot. You have a P treatments. You want to compare the effect of P treatments. Like 4 drugs are given to you and each treatment is like each treatment is replicated maybe Q time. Means your each drug will be replicated 4 times, 3 times, n time like that. So how many blocks we require, that is a basically capital N, which is called as PQ plots. But as you know, the experimental area is not homogeneous. The experimental area is not homogeneous. Then we divide these Q blocks, each of which are internally homogeneous, and then each block further divide into the P plots, and which will give us N is equal to PQ plots in all. So if we assign P treatment at random to in each plots in every block, then this is done independently for each block. So how is, I don't know whether you understood or not, but when just look at here how this particular design look like. Suppose just clear this, just try to understand this layout. If you're not understood that theory part, you'll be understand using this block. Suppose there are 5 treatments. Imagine there are 5 treatments, A, B, C, D. Okay. Each treatment, whatever this A, B, C, D, is replicated 3 times. Okay, means A is repeated 3 times, B is repeated 3 times, C is repeated 3 times, and so on. But now they are repeating in block. Important is that. Okay, so this is the, before it was like this, but now they are repeating in block. So we have formed a block which is a homogeneous. Okay, so that is a one criteria. That is a one criteria. And here we have a treatment which is A, B, C, D, E like that. Similarly here A, B, C, D, E like that. And similarly here A, B, C, D, E like that. So each treatment, which is 5 treatment. So 5 treatment, everywhere 5 treatment is there. And Q is repeated. Q will be the 3 times. So A will be 3 times. 1, 2, 3. B will be 3 times. 1, 2, 3, and so on. So this means that we don't have the homogeneous unit. So first we have created a homogeneous unit or homogeneous block, and then based on that we have allotted this treatment. So that's why this is importantly said that each block further divided into the p plots, which gives the result n plots in all, and we assign the p treatment at random in each plot in every block, है ना. 3 ब्लॉक बनाया, 3 ब्लॉक में जितने भी ट्रीटमेंट्स है randomly we have assigned, and hence since the experimental is not homogeneous, we have made homogeneous, one can use the 2A ANOVA. Okay. So how the model of 2A ANOVA look like? It's nothing but mu plus, I can say, effect of tau I plus beta, or I can use alpha I beta j, both will be fine. So tau I plus beta j, so this is my block, beta means it's a block, second effect, plus eij. So ti mu you know, yij you know, what is your ti, it's the effect of ith treatment, and what is the beta j, effect of jth block. Okay, effect of jth block. Then all assumptions are same, which we have studied in the case of 2A ANOVA. Okay, so these assumptions are same, so you can just copy as it is. In 2A ANOVA, you assumed alpha I and beta j is equal to 0. Here you have to assume tau I and beta j is equal to 0. Conditions are same. Instead of alpha, we are assuming the tau I. Again, there are two hypotheses. As usual, the hypothesis which we have seen in the 2A ANOVA, effects of different treatments and effect of different blocks. Sorry. And everything like the derivation which we did in the case of 2A ANOVA, same derivations we have to do it here, assuming that alpha I become tau I. So we have a treatments P, we have a blocks Q, so total number of observations or number of plots, which is this into this, which is PQ. Okay, G with the grand total correction factor become G square upon N. Total number of observation due to ith treatment is Ti dot. Okay, don't get confused. Ti dot. Total bola na. Ith treatment means Ti dot. And total number of observation due to jth block to I dot j. So then total sum of square for treatment, it is, sorry, total sum of square double summation Yij minus Cf. Usual definition. And how many observations we have? Total n, so n minus 1, which is pq minus 1. Similarly, treatment sum of square.
Hello
Treatment.
sir.
Yes, beta, bolo.
Sir, treatment or block factor A or factor B जैसे है ना same?
Yes, exactly. So treatment will be assumed like A and the block will assume B. But usually we never say A and B. We can call as a treatment and a blocks. Getting?
Yes sir.
So if you are assuming treatment over the treatment, so treatment summation over I. Okay, so it is single summation Ti dot, and since this dot, so this dot is represents for J. So I is running from 1 to P and J is running from 1 to Q. So this dot represents Q, that's why it is divided by Q minus here. Similarly, you can assume for the block. So block will be summation over T dot J. So this dot represents P. So to divide by P minus C. And degree of freedom corresponding you can write up. So once you get this, you can substitute in a table. You can just divide, like you can get other thing, like you have treatment, you have block, you have a total, take a difference, you will be get the error part. Okay, that is all easy, that I think you're already knowing how to get. And then as usual step, you have MSc, you can get like SS upon DF, you will be get mean sum of square for treatment, mean sum of square for block. Okay, so one can able to get very simple those things. That to get the f calculated, like mean sum of square due to treatment divided by mean sum of square due to the error will give us the f calculated for treatment. Similarly, mean sum of square for block divided by mean sum of square for error will give us the f calculated for block. Similarly, you can consider the degree of freedom. This is your p minus 1 and error. So you can say p minus 1 and error, q minus 1 error will give us the f calculated. See, in sometime what happened in when you perform this whole operation in computer or using any statistical software, they don't generate this f tab because they have a p value something concepts. I don't know how many are knowing about this, but whole I will tell you the whole analysis under statistical will work on p value. So maybe the who is doing the project and performing any kind of analysis using software, any software, maybe it is Excel, maybe it is Stata, R, etc., etc., Python. You have to always look at the p value. What is the criteria for p value? If that p value will be lesser than alpha value, alpha is a pre-level of significance. This is given to you. Okay. So the p value which you have calculated, if this value will be lesser than the level of significance value, then we reject the null hypothesis. Reject the H naught means reject the null hypothesis. So this is a criteria for like using the p value. So you can compare with the using statistical software, or you can do it with the help of manually. Okay, both will be give the same output. So one can try means like one way Anova, two way Anova. You can try in I will be say in using the suppose Excel software. Simple software. You should know how to perform the Anova. Okay, it's become like more interesting. Not Anova, maybe other T-test, Z-test, etc., etc. You can work out. Okay. So this is the criteria sometime asked in your objective questions. Even it is not there in your theory part, but you can understand कि criteria क्या होता है. P value पे basis पे हम लोग कैसे decide करते हैं कि hypothesis reject होता है कि accept होता है. So everything like it should be very easy. So criteria is like simple. Even this case. So this case, I think I don't feel like there is any doubt. You can have like very simple. Then using critical difference also, we can. I think this is the same derivations we did. Like so, when you reject the null hypothesis, if you reject the null hypothesis, then we go for the critical difference method. That criteria something always you remember. मैं क्या बोल रहा हूँ? When my hypothesis will be rejected, means that I am interested to know which treatment effect is same. Okay, which treatment effect is same. Aryan, just mute yourself. Aryan, mute yourself. Okay, so suppose I have a three treatments like mu A is equal to mu B is equal to mu C. Okay, and if I'm rejecting this, that means I am accepting this. Right. So I have means now this is accepted. That means this is accepted. Now this accepted means that now if I'm interested further, which treatment is same? Like mu A is equal to mu B or mu A is equal to mu C, like that mu B is equal to mu C. So in that scenario, I may go for always the critical difference method. This method is also known as post hoc test. Post hoc test. Okay, so it's very famous. There are very different post hoc tests like Tukey test, Jeffy's test. When you just work on the softwares under software, now you will be know these all names. Okay. But when you reject the null hypothesis, that means you have accepted this under H1, and then we can, like in manually we go for critical difference method, but there this difference method name is given, some name is there. Okay, some name is there which is called as a post hoc test, and under post hoc test we have a different method like Tukey's method, Jeffy's method. Okay, that is all methods are available to check whether the which treatments are equal or not. Okay, so that is like not in your syllabus, but just maybe when you perform this under any statistical software, we'll be know more about that. So if you reject the null hypothesis, then we conclude that all the treatment effects are not same. Okay, I mentioned all treatment effects are not same. In such a case, one may interested comparing the effects of two particular treatment. Matlab now I'm interested to checking two particular treatment. Okay, with the help of critical difference method. So critical difference method is only used when you want to compare any two treatment. Remember, sometimes they may be asked you in objective type of questions. When you reject null hypothesis, then we go for which method? Like Anova method, we can go for critical difference method. We can go for what type of method we are using? Z test, T test, like that. So you may understand the question according to give the answer. So that means I'm interested to check like whether LM is treatment for like LF treatment is same as the MF treatment or not. So we can calculate Y bar L dot, Y bar M dot, take a mod of this. Take the mod of, because critical difference they are saying, that means we are interested to get the difference. If this difference will be greater than this CD difference, then we reject the null hypothesis. That's the criteria we have seen. If you remember that critical difference method, it is same, the difference which you have used last class. See, if this difference will be greater than CD, then we reject the null hypothesis. Criteria is same thing I have written here. But यहाँ पे लोग ने क्या यूज किया है, ट्रीटमेंट की आर यूज किया है. यहाँ पे हमने क्या यूज किया है, we have used like Q. So that method you can always go through. And you can find standard error of that method, which is S square E upon 1 upon Q plus 1 upon Q. Because इसका जो variances होता है वो क्या होता है, S square ही होता है ना, into 1 upon Q plus 1 upon Q. So which you can simplify and we get 2 S square E upon Q. And this is your tabulated value. So the criteria is same. If this particular value will be greater than this particular critical difference, then we reject the null hypothesis. So reject H naught if mod of L dot minus Y bar M dot will be greater than CD, then you reject the null hypothesis. So this is your conclusion. So you may just take down that conclusion. Then there are certain advantage. It use all principle. The very important that this method is used. Like it uses all three principles like replications, randomizations, and local control. Design is flexible, that is any number of treatment can be used in any number of time. Means as I mentioned, I can replicate any treatment to any block. Okay, so that is a second advantage. It is a more efficient than CRD because your data is moving to two-way direction. Okay, one will be block, one will be treatment. Statistical analysis is simple. Statistical analysis is actually, you can say, not simple, but they have assumed it is advantage because they feel it is simple. That's why they are putting under the advantage. If the observation is missing, then it is estimated with the help of its missing plot technique. So there may be the one observation is missing. Okay. Might be the like one practical will be conducted by Chaya madam under this DBT start. Maybe the extension of this. I don't exactly remember the name, but maybe she is going to be conduct one practical under this, like when data is missing. Then there are certain disadvantage of RBD. Number of treatment is very large, then RBD is not convenient. So you can understand if the treatment like 8-9 treatments are there, then like randomly allotting the particular block, it's a difficult task. So when it is small, then it is like good. Otherwise, it is not feasible. One can use Latin square design. One can use like other designs, not RBD. If number of blocks are not internally homogeneous, then RBD is not convenient. It means within, I mean to say within, they should be the homogeneous. So the treatment which I am allotting here within this particular block, make sure that within this particular block it should be homogeneous. Then only RBD will be applicable. Otherwise, RBD will be not applicable. See, agar within this data is different, then that means within there will be more error. Between we can understand. Between there must be some error, but within there has to be minimum sum of squares. Okay. So that is the one of the disadvantage of your RBD. See, the whole derivation, everything will be similar to your two-way Anova, so that's why it won't be take much time. And this part is not there. This portion is not. So only till here it is there in your. With this, I think your unit 2 is over.
Hello, sir.
Yes, beta, bolo.
Sir, question for internal exam.
Unit 1.
Okay.
So you may practice.
हेलो सर.
हाँ बोलो बेटा बोलो.
सर कॉलेज कब से खुल रहा है?
अरे कॉलेज बेटा खुलने वाला है अभी, वो अभी खुल जाएगा होपफुल्ली, लग रहा है अभी, क्योंकि क्या है अभी सब ट्रेनिंग सब चालू हो गया ना.
तो कितने तारीख?
So I'm just let me just copy this and paste in your unit 2, which is this is practical number 4.2.4. So you can write down. Take down solution. So what you have to do, we need to find out how many treatments are there, how many. So how many treatments are there? Anyone can tell me?
5. 7.
7, correct. So you can write down, let P is equal to number of treatment. See, this is exactly same way which you did in the two-way ANOVA. Okay. So if you know the two-way ANOVA, you can very easy to do it with the this one also. Number of blocks, which is 5. So total plots become PQ, which is 35. Now we need to obtain Ti dot. This dot represents the total over the range of first treatment. Okay. So what could be total of this one? So it's a first treatment total. Similarly, T2 dot, T3 dot, T4 dot, T5 dot T6 dot T7 dot. That means total of all treatments, which will get the total of all treatments. Similarly, get total of T dot J, right? T dot J. So T dot 1, T dot 2, T dot 3, T dot 4, T dot 5. So we have a total 5 blocks, na? So you will be get the 5 totals. And then based on that, you need to get the grand total, or you can call the. So what could be your grand total here? What could be your grand total? When you add these all, or you can add these all, you will be get grand total. So T1 dot, मतलब first treatment लेना है आपको over the range of J. So this is over the range. This is your I data, right? This is your I data, 1 2 up to P. This is 1 2 up to Q. So over the range of Q ले रहा हूँ, so we have to add this all. So that will give us, I think, 1053. Anyone have calculated this? They can put in the chat box. Just make addition of this treatments. You will be get first treatment ka total. Similarly, second one, third one, fourth one, fifth one. Just check whether this is right or wrong. 62, 61, 72, 78, 61, 66. And this is 104, 78, 89, 94. And this one become 86.
हेलो सर.
Yes, बेटा बोलो.
सर T1 डॉट का वैल्यू 53
क्या हो नहीं आ रहा है?
सर आ रहा है, लेकिन सर टोटल T5 तक ही आएगा ना, क्योंकि सर वो G के उस साइड T1 डॉट TI डॉट और इस साइड T डॉट J.
फर्स्ट ऑब्जर्वेशन क्या रिप्रेजेंट करता है तुम्हारा? 1 क्या रिप्रेजेंट करता है? I.
यस.
I मतलब क्या? I क्या ले रहा है? 1 2 up to P.
हाँ, आई ट्रीटमेंट.
ट्रीटमेंट. तो कितना ट्रीटमेंट मेरे पास है? टोटल 7.
यस.
तो 7 आपको ट्रीटमेंट का टोटल मिलेगा. सो फर्स्ट ट्रीटमेंट, सेकंड ट्रीटमेंट, थर्ड ट्रीटमेंट, फोर्थ ट्रीटमेंट, 5 6 7. Similarly, block. So this is your block. So 5 blocks. तो कंफ्यूजन यही होता है. बहुत सारे बच्चे इधर इसको एडिशन ऐसा करने का कि एडिशन ऐसा करने का, उसमें कंफ्यूजन हो जाता है. So don't get confused between that. Okay. So that's why you assume treatment and block. According to that, you can work. I hope everybody joined with their roll number with name. Abhishek Shahani joined with your roll number. Beta. Pawan Dikshit, Pawan Gupta. Just join with your roll number. Otherwise, like your name will be only recorded. And once you get this, is just check whether what is your grand total. Let me know what is your grand total. Is that coming 453? Just check. What is your answer? What is your answer of getting? Is that 88? Just check. And once you get the grand total, you can find a correction factor, which is G square upon N, which is simply 5863.5. 1143. Then similarly, you can based on this treatment totals ka, you can find summation ti dot square summation t dot j square. So, and then summation over the range of y I j square. So this would be 6061. This would be 41401 29719. Just check whether this is right or wrong. And then based on that, you can find treatment sum of square, which is usual formula. I takes value 1 to p. P bola to it is t I dot square. So whichever is dot, based on that you have to write the parameter minus here. So don't get confused between whether it is divided by p or divided by q. Whichever is dot, there based on that dot we have to consider. Just keep remember these dots. So I is running from 1 to p, j is running from 1 to q. So if it is second dot, that means you have to divide by q. Okay. So when you calculate this answer, this would be 80.6857. Please just calculate this. It is very simple. This data you have with you, like 29719 divided by 5 minus 5863.1143. When you subtract, you'll get this. Similarly, you can get block sum of square, which would be the formula summation 1 to q t dot j square upon p minus c. And this would be 51.3142. And once you get treatment and block, you can find total sum of square, which can be, this is also notationally one can use h square treatment, s square block, or s square t means total, which will be double summation ij yij minus cf, which would be 197.8857. I hope everybody getting this. So in case if anyone not getting, let me know. So around 24 students have joined. So you can just cross check whether this is right or wrong. And then let me know with it. What is your answer? Exactly same way we have to work as you worked in 2A Anova. Okay. Then after this, we need to be write down the hypothesis. We need to be write down the hypothesis, which is H naught. We have to write down, because you have to frame two hypotheses. One will be for treatment. So what is your hypothesis? There is insignificant difference among the effect of the effects of different treatments versus H1 treatment, which is not H naught. This is the one hypothesis. Similarly, if you consider second hypothesis, I'll just copy this and paste here. Just paste here. So this is for block. So this you can use it for block. Instead of treatment, now I'm going to use block. Different blocks. This is for block BL. So these two hypotheses you are supposed to be right. And then based on this, we need to create the Anova table. So it could be source, everything is same. Everything is same. So instead of now I have this factor A, factor B, I'm going to assume simply your treatment and blocks. And total will be the same. P and Q and everything will be same. Everything is going to be same. This will going to be changed. Very so now whatever entry you have kept there, you can write it down here. So we have here treatment. Here we have a block. So treatment 7, so it is 6. Blocks 5, so it is 4. So total 35. So 35 minus 1, 34. So when you subtract this out of this, it will be 10. So it is 24. Similarly, you can this data you have already computed. So 80.6857. I think everybody getting same answer. Any changes in the answer?
No,
Or
sir.
anyone maybe confused how to calculate these values or don't know how to do it? Because this is all you know, your technique, how to do it, these problems using calculator within 8 minutes, within 7 minutes. Okay. Then MSS you get it degree, this SS upon degree of freedom. So 13.4476. Let me just finish this Anova table, then we can start. 12.8285. 2.74 by 2. FCal become 4.8985, 4.6730, and just check these values. This is F6 comma 24. How much it is? That 2.51, and F4 comma 24, which is 2.60 or 2.78. Just confirm this. 2. So this is also greater than this one. This is also greater than this one. So both are rejected. If the FCal will be greater than F tab, then we reject the null hypothesis. So in both the cases, we have found that the treatment effect is also rejected and blocks are also rejected. So you need to be write down that you need to be just take down those results. Okay, since FCal will be rejected, FCal will be rejected, FCal will be greater than F tab, therefore we reject the null hypothesis. Like, you can just finish it. This. I hope you can able to write that conclusions part. If you are not, then we will see in the next. Anyone, any question? Any question how to proceed about this? Any idea? So I think I have already uploaded this practical RBD. So remaining one problem you can try to do. Okay, remaining one problem you can finish it. Exactly same way you have to do it. Okay, exactly same way. So you can just finish that, and so we can verify your answers maybe the next class. Okay. Now here one part is remaining, treatment effect D or F. D or F. Okay, we have to just compare these two treatments. So next class I will tell you, we will verify the answers of second problem as well as how to test these two. That we will see in the next class, maybe in Saturday. Okay, and then we can see the
हेलो
problem.
सर,
हाँ बेटा बोलो.
सर प्रैक्टिस के लिए क्वेश्चन आपने फ्रेम किया है क्या, जैसे पहले किया था?
नहीं, प्रैक्टिस मतलब सिंपल ही क्वेश्चंस है, मतलब इतना कुछ उसमें मिला नहीं मेरे को फ्रेम करने के लिए. सो जस्ट गो थ्रू बेसिक क्या क्या मतलब बेसिक क्वेश्चंस पूछते हैं. So even we can like last 30 minutes on Saturday we can just do the recap, like what type of questions can be asked like in your examination. तो आप खुद भी पढ़ो एक बार कैसे क्वेश्चंस क्या पूछते हैं. ओके, तो आपको थोड़ा और आइडिया आएगा, मतलब जैसे कि वन में अनोवा में अगर फॉर एग्जांपल के ट्रीटमेंट्स है तो क्या डिग्री ऑफ फ्रीडम होगा उसका. सिंपल क्वेश्चन, स्ट्रेट फॉरवर्ड क्वेश्चन रहेगा. केवल लॉजिक क्लियर होना चाहिए अपना. इट शुड बी लाइक लॉजिक शुड